So now we're going to actually be learning how to code, or hopefully like the basics of coding.
So now you can open up RStudio.
The people who downloaded the RStudio, open RStudio, obviously. So for people who didn't and still want to code along, I'm gonna be putting this video on our website along with the script that we're gonna be writing for this session. So you can follow along. And if you have any questions, you can always obviously contact me. And for next session, hopefully you'll be like you want to code with us. So hopefully that I've convinced you that this is gonna be useful. And I'm gonna give you a disclaimer. I am not a professional coder by any means. So people who professionally code are doing a completely different thing. And this is what I'm trying to tell you. You don't have to be a professional coder. You just have to know what you can do with coding in the field of law. So is everybody ready to get started with a little bit of coding? We have about half an hour that we can go through some basic stuff in R programming. Okay, so let's start and see what R is all about. So R is a programming language that's being used with a lot of data scientists. The reason it's a little bit more preferred when it comes to data science is because it's geared towards data science. So like it makes it easy to analyze data. You're more than welcome to try to learn other programming languages. So I code in Python as well. But I found that R is the easiest to work with. Okay, so with that being said, sorry, you see this is actually the number of LSAT takers in the US, and they're great. I don't know why it was there. I was I think doing some analytics. Yeah, so they're great, and the number of people who took it. That's from the LSAT website. Just something to put it out there. So R at its core is a calculator. So what you can do, for example, if I want to say 2 + 2, and you put it there, and the way you would execute this line is not by pressing enter. You have to press Control Enter. For people who are doing this, so I'm going to do Control Enter. And once you do Control Enter, you're going to see your result over here. So this is where you're going to be writing your code. This is where you're going to see the results. Okay. Or just whatever you want to put, 2 × 8, for example, and 16. That's just like basic calculator, which is not really fun, I would say. But these numbers obviously are going to mean something later on when you're analyzing some stuff. As I mentioned, the rate of descent, the number of decisions in a certain year. So these numbers are going to mean something. So you're going to have to assign these numbers to something that you feel like, well, you're going to have to assign them. So the way you assign a certain number or any sort of variable, we're going to go through all of them, is by doing this. So let's talk about, I'm going to show you, by the way, for anybody who's coding, if you put this hashtag thing over there, it's gonna basically make you write whatever you want without actually executing it as part of the code. So if you want to put comments on, let's say, a certain code, and you don't want it to execute, obviously, that's gonna be, it's very important, because when you're coding, let's say, thousands and thousands of lines of coding, you don't want to go through everything and be like, what was this? What was this? You want to make sure that you put comments there saying, oh, this is where I'm doing this, or this is where I'm doing that. So let's say, let's get some variables. Okay, and that's not going to execute. So even if I press Control Enter, it's not going to do anything. Okay, so let's get some variables. So what are the types of variables that we're going to be using in the field of law? One is, as I mentioned, the numbers. So let's call a variable var1. Okay, and the way we assign this in R is by putting this and this. So it's this thing, and then dash. And then I assign a value to it. So I say, for example, 3. Oops, is it working? 3. There we go. Okay. That's gonna save that variable as number 3. So now you can put equals if you want to. You can say var1 equals 3. It's gonna do the exact same thing. The reason I do this because this is the preferred way of doing it in Python. If you're more comfortable, if you've done coding before, because in basically all the other programming languages, they use equals. If you're more comfortable doing equals, then go ahead and do it. Yes?
Is there any way you could zoom in or make it all bigger? It's a bit hard to see.
I can see if there's anything I can do on that one.
Maybe see at the top, you can zoom in the screen.
Where?
Very top. Our studio, is that a way?
Oh, this one?
Yeah. Just like zoom in a bit more. One more. Is that better?
This is good? Do you guys see it?
Yeah.
Yeah? Okay, cool. So, yeah, so and then let's say, for example, bar 2. You don't even have to assign it a specific number. You can say 1,000 or 100 times 3, which is what we did, 3,000, right? So these are numbers that you can get from obviously R. There's other variables that we're going to be using as well. It's called characters. And the way characters work, let's call them var3. Okay. And what var3 does, and if you want to put a specific character, you can, for example, if I want to say hello, I can't just put hello like this because R doesn't accept that as a character. So what you're going to have to do is put them in quotation marks and say hello. And you just execute that. And now that variable is saved as hello over here. And then let's say var3, or sorry, var4, and we call it class. At any point, if you guys have any trouble and like it's not working for you or like something's happening, let me know and I'll try to explain it a little bit more. Once we get into it a little bit, you're gonna see that it's gonna get a little bit more, it's gonna require a little bit more effort. So we have numbers, we have characters. These two are obviously very important. We're gonna be using in our legal data analytics. There's one more class of variables that we're gonna be using a lot, and those are the logical variables. So logical variables are just either true or false. So let's say if I have var5 and I say it's true or t, doesn't matter. You can do true or you can do t, it doesn't matter. var6, I'm just gonna say f because as I mentioned, it doesn't matter. It's gonna, so obviously the true or false are not gonna be useful like this. You're not gonna call something true, but they're gonna be useful when you're trying to take some data out of something and you only want to take a specific part of data where a condition is true. So let's say you're analyzing the judge's characteristics, but you don't want all the judges. You only want to take Justice Abella's, for example, part, and you don't want to take all the data. That's where you're going to be using the logical variables, and I'll show you how to do that. And then what I also want to show you that you can do.
Excuse me, sorry, I have a question.
Yeah.
So, when you say var6, I thought like variable 5 just represents true or false, like in.
Yeah.
So why do we have variable 6 representing false?
Oh, that's just an example. So I'm just putting it there so I can show you, for example, I want to show you the operations that we're going to be doing. So you're going to see where it comes out as true and where it comes out as false. So we're going to have some logical operations happening. I'll show you in about 2 minutes. And you'll see what I mean when I say that. So let's say if you want to do operations on your variables, okay? So I want to, first of all, let's say numerical. If I want to say var1 plus var2, and I just want to see how much it is, I just do that and it's going to give me, because we had our var1 as 3 over here, and then var2 was 1,000 times 3, which is 3,000. So if I put var1 plus var2, R is automatically going to recognize that I'm talking about those two variables. So it's going to say, okay, so 3 plus 1,000, 1,003. Okay, so that's how you're gonna add the numbers. And don't think of these numbers as mathematical numbers that you're gonna have to memorize. Absolutely not. Numbers are very important in the field of law. We know there's so many numbers that we deal with on a daily basis with cases. Again, I told you the number of cases in a certain year, number of dissents, and all that. So they're very important. So we're going to be using those numbers for that purpose. Or you can say var1 times var2. And again, it's going to realize that both var1 and var2 are numeric variables. So it's just going to add them together. But what if we don't want to add numbers? We want to add, for example, these two together. We want to say, like, we want to create hello class. We're not going to be able to, for example, do var3 plus var4, because if we do that, it's going to give us an error and say non-numeric argument to binary operator. So it's not a number. You can't just add it like that. So in order to put two characters together, there is a function in R called paste. And you do paste in parentheses. It's going to open it up automatically. And you're going to say var3 and var4. And if I do this, it's going to basically put everything together. Okay. You can, so automatically separates them by a space, but you can also tell R what do you want it separated by. So I can add an option on top of that saying sep equals, and then I say I want it to be separated by a semicolon. So if I do that, then R separates them by semicolon instead of separating them by space. So you can also put space over here, which is going to do the exact same thing as it would do. So that's basically how it works. So for numerical operations, you can just add them together, subtract them together, times, whatever you want to do. That's just operations. In order to add characters, you're going to have to use the paste function. Okay, and that's going to be important, and I'll tell you where. Then we have the logical operators, as you were talking about. Sorry, what was your name?
Vivian.
Vivian. Yeah, so Vivian, you were talking about this. So like, this is where the true or false are going to be coming in handy. So logical operations. Okay, so logical operations are something that gives us a value, either true or false. And there are some important ones that I want to talk to you about, and I'm going to go through each of them because I think they're important for you to know, because these are going to be the main ones that you're going to be using. Okay, so when you want to see if something is equal to something else, okay, that's one thing. When something is not equal to something else, when something is bigger or smaller, something, you have two logical operators and you want to see if both of them are correct, or you want to see either of them are correct. So if you want to see if something's equal to something else and you want to get a logical operator, so true or false, you're going to have to use the double equal sign. And here's what I mean. Okay, so let's say I want to see if var1 is equal to var2. It's not, right? 3 is not equal to 3,000, or yeah. So if I put var1 equals var2, so keep in mind, I'm not doing equals, just one equal, because when you do that, it's going to assign that together. So it's going to say var2 is equal to var1. So that's going to say var2 is 3. But when you put 2, now you're asking to see whether these are actually, you're asking are these the same? And if I do that, then it's going to tell me that no, it's false. Okay, so again, I can do this. This is a good thing. I can see if characters do the same thing with this one. So I can say var3, and instead of saying equal to, if you want to say it's not equal to, instead of putting 2, you put the exclamation point and that, and var4. What are we expecting for this? It's not equal. Are they equal? var3 says hello, var4 says class. They're not in any way equal, right? So if I put this, then it's gonna say true because they are not equal, right? Whereas if I said they are equal, it's gonna say it's false. You wanna see, for example, let's keep this here. There's no one. Okay, this is for numbers, and this is again gonna be useful. So you want to see if var1 is smaller than var2. What are we expecting here? True? Yes, it's true because 3 is less than 3,000. And again, this is going to be useful. I want to give you a legal context so you don't get lost in the numbers. Let's say I'm trying to take cases that I'm working with, and I want to only take cases that are 1980s and onwards. Okay, I'm gonna have to assign a value and say, give me the cases where the year is more than 1980, and that's how I get it. So we're gonna get into that. I just want to give you the context so you know that these are not just for mathematics. We're not like trying to use this for math. This is going to be useful later on when you're basically manipulating data. That greater or smaller signs don't work with characters, needless to say, because no character is less than one character. Any questions so far? Is everybody following along? Who thinks it's very hard? Fantastic. Okay, that's great. So let's do one more. So I'm gonna say var3. You don't even have to put all values. So you say var3 is equal to hello. Is this going to, what's the false? False. And well, you guys are saying so. Yes, it is false because var3 is actually hello with a small h. What we put over here is capital H. So it is case sensitive. So be careful of that. And I have fallen into the trap of this one for many, many times. Yeah, so be careful of that. Now let's see if we're comparing two logical operators. And we know with logical operators, there is two things. We can do an and or an or operator. So we can say, give me, if we want to see either of these are true, we can say this is true or this is true. And if either of those are true, it's going to return true. But if we put and we say we want this to be true and this to be true, and it's going to have to make sure that both of those values are true. Again, I'll give you an example. I say I want to take cases where I'm looking at cases where the year is more than 1980. And I'm also looking at cases that have less than 50. I'm looking at the years that have less than 50 cases per year. Now I have two conditions that must be met, and I'm saying and. So if any of these is false, it's not going to be included in the data that you're going to be getting. So let's say, for example, I want var1 to be equal to hello, and this is how you put and, so you just the ampersand sign, and I want var3, let's call it var3, and I want var1 to be equal to, what was that? 3. Okay? When I say and, so again, what are we expecting here? This is true, and this is true. So if that's the case, and both of these are true, then we're returning the value true, right? So if I say, for example, this was 4, I want var3 to be equal to hello, and I want var1 to be equal to 1. Not both of these cases are met. So what we're gonna get is false. But if I put an or sign, I'm gonna do this, but I'm gonna do it with an or. So I'm gonna do or, and this is how you put or, just that line over there, okay? If I do this, then I'm just saying, if this is true or this is true, just return true. And this is true, we know this to be true, so obviously it's gonna return true. Any questions so far? Anything confusing about this part? Okay, great. So once we know like how we're gonna be using variables. So far we talked about 3 types of variables. So we have the numerical variables, 1, 2, 3, 10, whatever. We have the characters, whatever you want to put, Abella, Cote, anything, hello, whatever you want to do. And we have the logical operators. So we have true or false for any conditions that we want to be met. So I'm gonna put the things over here. So we have equal, that's for equal. We have not equal. We have less than. We have more than. We have equal or less than, and equal or more than. What else do we have? We have and we have or operators. Okay. So now let's talk about what if I'm not dealing with just one number, I'm talking about like a whole array of numbers. Again, years, think about the years. So you have 1980, 1981, 1982, 1983. So you have a whole array of numbers. You're not dealing with just one, right? So what you're doing, you want to have a vector. A vector is something in R that contains more than just one value. I mean, it could contain one value, which is just that one value. And to be fair, R actually stores that one value as a vector with a length of 1. But it's not really useful. So what we can do is, let's say, now we want to talk about a vector. I'm going to call it vec1. And then let's do this. And the way you create a vector, and when we're talking about vectors, is a whole series of numbers. I'm going to see if I can write it here. Never mind. So let's say I want to have a row of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the way I do that is I put C, and whatever I want to put, I want to separate them by commas. So I want to put 1, 2, 3, 4, 5, 6, and 7. Let's just put there. Okay. What it's going to return to me is if I want to, let's say, by the way, I'm going to show you print this function. So the print function is if you want to just print something. So if you want to show something over here, you use the function print, and I say print vec1. And what it's going to show me is a whole array of numbers. So now we have a vector that has 1, 2, 3, 4, 5, 6, 7. Okay. It doesn't have to be numbers, but I'm just going to show you one more. So vector 2, it could be names. So, oops. So it could be, let's say Bella. It could be Wagner. It could be, oops. It could be Cote. It could be, oops. I don't know why I chose the hardest name. And Jamal, for example. Okay, so now if I want to print vec2 instead, you're going to see a whole array of numbers. I'm at characters over there. So vector can contain anything you want in there.
Sorry.
Yeah.
C, or is it a column?
C? No, C is just indicating in R that you're basically making a vector. So if you want to create a vector, you just put the C, and any element of that vector has to be separated by a comma. Okay? So that's how you make it. I'm gonna.
Do you have to call them vectors, or can you?
No, you can call. Let's call them Sabrina. C. Give me your favorite numbers.
7,
7,
21,
21,
35,
35,
49.
49. Okay. So if we do this, and I say print Sabrina, we're just getting. It doesn't matter. You can call them anything. It's just you're assigning a name of a variable to it. So that's really not important. It becomes important when you're dealing with a lot of data, so you want to make sure you name them properly. If you have like 100 different variables, you don't want to call them A, B, C, because you're gonna be like, what is A? So you want to make sure you do something specific. You cannot have any spaces in between. So if you want to have like something space, like you want to say, judge data, for example, you can't just be like judge data. Doesn't work. So you're going to have to call it judge underscore data. Just a quick heads up. So let's just, for the vectors, let's just quickly look at some functions that I think are going to be very useful. This is the only part of programming that you're going to have to know by heart. I mean, in any language, you, I guess, have to know some things by heart. But these are the functions. So these are something that make your life just much easier when you're doing it. So the first function that I want to talk about is the repeat function. Okay, it's called rep. And what this rep function does is it repeats a certain thing that you want any number of times that you want it. So let's say I want the character Ari to be repeated 10 times in a vector. Okay, so I put Ari and I put comma, and then I put the number of times that I want that to be repeated in the vector. If I execute this, you're just gonna see Ari, 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 Ari. So 10 times. If I wanna repeat not a character, it's a number, so I wanna repeat 0 10 times, and I'll just get 0 10 times. That's the repeat function. Okay. The other function that it is the length function. Okay. So the length function tells you what the length of that vector is. So what we're looking at is, for example, length of our vector 1. So what is the length of our vector? 1, 2, 3, 4, 5, 6. There's 7 elements in vector 1, right? So if I put length vec1, I'm getting 7. If, what else? There is the sequence thing.
Is it the launch and code?
Yes.
Oh, sorry.
No worries. Yeah, come in. Come in. If you miss, you missed some parts of it, but it's okay because this is going to be available online anyway. So you can just follow along, and I'll send the script on our website as well. So there's the sequence. So the sequence basically allows you to do a whole sequence of numbers and only numbers. Let's say I want a sequence of numbers between 1 to 10. Okay. And I do that and I get 1, 2, 3, 4, 5, 6, all the way to 10. This function is a little bit more useful than just this. It allows you to also define in how many steps you want them. So for example, I want to get numbers from 1 to 10 in the steps of 2. So I want 1, and then I don't want 2, I want 3, right? So I want the numbers to jump 1. So if I say in the steps of 2, then I'm making 1, 3, 5, 7, 9. So we're not really talking about even numbers over here. Any questions so far? Is everything clear? Is anything confusing?
Yeah, sorry, I did not understand the last part. Like, how do we get to each one number?
That's this number over here that tells R to step how many elements that we want. So what I'm saying with this, I'm saying, give me the sequence of numbers between 1 to 10 in the steps of 2, right? So if I say, give me the number of numbers between 1 to 10 in the steps of 3, it's gonna give me 1, 4, 7, and 10. So it jumps that many times in the sequence as you mentioned it. Good, no worries. There's the sum function, which gives you the sum of all the numbers within a certain vector. Let's say vec1 again. And this is the sum of numbers in vec1, which is 1, 2, 3, 4, 5, 6, 7. I am 100% sure that's true. So, and then also maybe mean. That's the average of the numbers that you're gonna get. Like 1 again, let's say. So the average is 4. And we also talked about the print. Okay. I want to now tell you a little bit about how to access certain things in a vector. Okay, I think we'll, in the next maybe 10 to 15 minutes, we'll do this. And I want to talk about data frames too, but I think I'm gonna leave it for next session because this is already enough for people to sort of take it, I feel like. But let's talk about vectors, and let's talk about, first of all, vector operations and how you can access something in a vector, because this is gonna be absolutely important when you're dealing with, let's say, you know, rows and rows and columns of data, and you need to just pick specific data from that table. You don't want to analyze a million cases. You want to sort of filter them. So let's first do, I have vec1. So let's do vector operations. And let's say vec2 is, let's do this. So we will say that it is just 2's. Okay, I want 2's to be repeated 7 times. Okay. Oh, one more function I totally forgot to tell you about, and it's very important. Did I talk about this? Length. Did I? Okay, yes. Okay, good. I did. Sorry. So that, right? So now I have a vector that has 7 2's, and I have another vector that goes 1, 2, 3, 4, 5, 6, 7. But I just want to make sure that I have them right. So I want to make sure that the length of these two cases are actually the same. I can just use that logical operator that I was saying. So like length, geez, what the hell? Length of vec1 equals length of vec2. What are we expecting? True. Yes, it's true, because the length is the same. So now if I wanted to add these two, and keep in mind, so these values, 1, 2, 3, 4, they're numbers now. So whatever you did with the operations for the numbers, you can do the exact same thing with the vectors, because vectors are just numbers. I mean, in this case, right? So if I wanted to say, for example, vec1 plus vec2, instead of getting just one value, because we're adding, you know, number plus number, now we're adding each element. And what we're getting is 3, 4, 5, 6, 7. Why? Because it was 1, 2, 3, 4, 5, 6, 7. And then we have 2, 2, 2, 2, 2, 2, 2. So 1 plus 2 is 3, 2 plus 2 is 4, and so on. So if you want to add two rows together, right? So let's say the number of cases in 1980 plus the number of cases in 1981, okay? And you want to add them together just to see what the data is. Yes. Hi. Sorry, which this?
Yes.
Okay.
Why is that true?
What is the length of vector 1? Let's look at vector 1 now. This is vector 1. What is the length of vector 1? Okay. And what is the length of vector? Where is it?
It's on 59.
Oh, 59. Oh yeah, so vector 2. What is the length of vector 2? 7. So all I'm asking is it true that the length of vector 1 and the length of vector 2 are equal? And that's what I'm saying. So, and this is useful again in cases where you have so much data and you just want to add them together, but you want to put it somewhere in your code just to make sure, just as a safety, saying that, oh, I'm doing this right? I didn't miss anything. I didn't miss like one data over there, for example, case. So if that returns false, then you're going to be like, okay, that doesn't make sense. I have to go back, see if I missed something. I missed maybe a variable over there, right? So that's what you want to do, which is going to be a little bit like useful later on, as you'll see. So vector 1 plus vector 2, we saw some numerical. So if I had vec3 again, let's go, no, vec3, let's go with vector 2, the previous vector 2 that we had. Actually, you know what? I'm going to call this vector 3 because it's going to get confusing. So vector 3, and I'm going to make another vector, vector 4, and I am going to put and 1, 2, 3, 4, 5. Okay. What is this going to do? What is this code going to do?
Create J 5 times.
Yeah, exactly. So if I do that, And if I just print vec4, just j dot, j dot, j dot, j dot. Okay, so now I want to add these two together. So vector 3 and vector 4. What would I do? We talked about this with the characters. What did we do when we wanted to add two characters together? Yes, paste. So you can do the exact same thing over here. So you can say paste vector 3 and vector 4. And if I do this, again, element by element, you're gonna see them just getting added together. So the first element of vector 3 and first element of vector 4. Second. Again, I can do, say, for example, separate them not by, separate them by a dot, for example. And you're gonna see that it's separating them with a dot, right? So that's that. So let's look at, for the next 10 minutes, how we can access these. So now we have this vector with a certain number of elements in it, and we need to access a certain specific things in it. Okay, so I have vector, I'm gonna make another numerical vector, but this time maybe a little bit longer. Vector 5, let's call it. And we'll do a sequence of numbers between 1 and 100 in the steps of 3. Okay, that's my vector 5. I want to see in vector 5, I haven't seen vector 5 yet. I don't know what it is. Okay. I want to see what the fifth element of this vector is. I don't want to see all of it. I don't need to see all of it. Okay. I just want the fifth element of this vector. That's all I need. Okay. So what you can do is use these brackets. So these brackets, open and close, whatever you put inside that, as long as that value is true, it's going to show you what you're requiring. So vector 5, I want the fifth element of vector 5. It's 13. That's the value of vector, the fifth value. So like if we actually look at this, vec 5, oops, sorry. If we look at vec 5 now, look, 1, 2, 3, 4, 5. The fifth value is 13. And that's exactly what it gave me. That's what I got over here. So vec 5, I want the 10th element of vec 5. It's 28. Okay. I want every element except the first element. Okay. I can say, give me vector 5. Don't give me the first one. So minus, it tells you what exactly you don't want. Okay, so if I say that, it's going to give me all the values in it except the first one, which was 1. Okay, so if I do this with vector 3, which was the name of our judges, and I said I don't want the first item, I want everything other than the first one. And you're gonna get that. Abella's not there, as it is right now. Sad, I know. So what else can you do? So let's say you want, sorry, yeah, go ahead.
When do we use the print function?
Print function is whenever you want to just print something and you want to see it over here.
So why didn't we say print vec 5?
You can,
Yeah.
if you want to. I just put it there because sometimes, like in some cases, you have to say print, but in some cases you don't have to. But I always encourage you to put print because that's just the safest way of doing it. Because sometimes you're going to get an error and it's going to say, oh, it doesn't work. But if you put print, you're safe. So it's going to actually print everything. Okay. But you're right. Yeah, you can actually put print. Let's say I want the second vector, the second element and the fourth element of vector 3. Okay. So now I want two things. I want two elements. Sorry, did you have a question? Oh, okay.
It was going so-
No, it's okay, yeah, let me know if it goes like, too fast, I can come back to these. Vector 3, and let's say now I have to make a new vector telling R which elements I want. So how do we make a vector with C, right? I want to get the second element, the fifth element, and the 10th element of this vector. Oh, sorry, not the 10th element, we don't have a 10th element. So the second element and the fifth element of that vector, we're getting it, okay? So guess what happens if I put a minus sign over there? It's gonna do the exact opposite. It's gonna give me the ones that are not the second and not the fifth. So any item you want, you put it in there. Any items you don't want, you can just say, okay? Here's a question for you. If I don't know how many items I have, how do I get the last item?
Measure the length and then get recorded.
Right, yeah, I can say, if I want the last item, and I say vec 5, and I want the last number. So the last number corresponds to the entire length of that vector. So give me the last item, as in give me the item which is equal to the length, and that is 100. And what else can I do over here? So you can sort of combine these functions as well if you want to. So if I have vec 5, okay, and I want to get, let's say the second, the fourth, like all those things, I can make a sequence, okay? Give me the vector 5 of, let's say, starting 2, going to 10. So I want the second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th element. This is not the vector itself. This is what I want from this vector. So sort of vector within a vector, but don't think about it like that. Just take this. What does this give you? This gives you, like if you don't look at this function gives you 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you put vector 5 and give me 2, 3, 4, 5, 6, 7, 8, 9, 10, it's going to give you those elements within that vector, which is 4, 7, 10, 13, 16, 19, 22, 28. What's it? 28. Any questions so far? Is everything good? Yes, you can go ahead.
The last part, I do not understand the last part.
This one?
Yeah,
Okay, so what does this give you?
Yeah.
What does it give you? Tell me.
okay, so like,
Let's put it here, okay? Let's put sequence 2 to 10, right? If I put sequence 2 to 10, this is 2, 3, 4, 5, 6, 7, 8, 9. This is that, right? So if I don't put that and I say, give me vector 5 and give me 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay? I'm getting the exact same thing. Remember, there's not one way of achieving what you want to achieve. There's so many things you can do. There's so many ways to achieve the same thing in programming. You can choose to put this. If you're more comfortable doing this, do it. It takes more time, but if you're comfortable with that, do it like that. You know, if you're more comfortable just making everything shrink, use that one, right? What if I want, and this is what we talk about, so some logical operations. I want from vector 3, which was the names, okay? I want the only element, it's sort of redundant, but like you'll get what I mean when I say. So I want in vector 3 only the element that is equal to Wagner, for example, okay? What I can say is R, give me in vector 3 something in that vector 3 is equal to Wagner. okay? So give me this where this is true, okay? And what it's gonna do is just give you Wagner because, yeah, we just put it there, okay? What if I say, R, give me something, give me all the elements where vector 3 is not equal to Wagner. So you can sort of play with this. So you can put any logical characters in there. Okay, I can say, give me, for example, vector where vector 3 is not equal to Wagner and vector 3 is not equal to Abella. So now I have two logical operators and I said and. Both of those have to be true. Okay? And I get Cote, Carcassonne, and Jamal. Exactly what I asked R to do. What else? Let's just play with this a little. So I'm just trying to see what else we can do. Yeah, I know. I was just gonna say, just quickly going through one or two more things over here. So let's, for example, look at vector 5, okay? And say, give me vector 5 where vector 5, this is what we talked about, remember? What was vector 5? Let's just look at it, for example. 1, 4, 7, blah, 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 blah. I want only the variables over here that are greater than 50. How would we write it? Can somebody help me write this? What do I want from vector 5?
Big 5, bigger.
So I want only the variables in vector 5 that are more than 50. And that's what I'm gonna get. One more useful function that I'm gonna give you is the which function. So this, if you want to practice at home, is actually very useful. Which function, you can put something that's true in it and it will tell you what it corresponds to. So I want to, for example, say which element in vector 3, okay, is equal to Wagner. Okay, so I'm going to say which element in vector 3 equals Wagner. What is this? That's the second element. That's just telling me that in vector 3, the second element is Wagner. What happens if I put not equal to Wagner? So which one of the vector 3 are not equal to Wagner?
First one.
Yeah. That's going to give you everything that's not. So if you want to see which elements correspond to a certain thing, certain logical operator in your data, that's how you do it. So for example, I say one more and I promise I'll let you leave. Which elements in vector 5 are greater than 50? Okay, this is different than actually asking, give me the elements. Remember, because when you're asking to like R to give the elements, it's going to give you the actual elements. This is going to tell you the number of elements and which element it is. So there is a slight difference. Okay, so if I ask this, it's going to tell me that 18, 19, 20, 21st, all the way to 34th element are bigger than 50. It's not going to tell me what it is. But guess what? I can use this because this is exactly what this is giving me. So if I say vector 5, give me vector 5 of the which of the vector 5s is bigger than 50. And it's going to give you the exact same thing that that one gives you. That one's just easier. But I just wanted to show you, so you don't have to use this. But this is what R is doing. It's telling you, okay, so which of the elements are bigger than 50? I'm gonna put that over there and I'm gonna give you the results. Which by itself just gives you the number of elements. So which, well, we already put that. And yeah, so that is basically how you interact with the elements in the vector. There is so many ways. So I really highly encourage you to take vectors, create vectors in R, anything you want, do numbers, do, characters, do whatever you want to do, and then try to access them. Try to see how you can access them. If you have any problems, just email us. Our email is over there. You can see it. You can contact me directly as well. This is going to be available in our website as well. I'm going to put this script that we worked on in our website so you can access it once you have R, and you can take a look at it. The event is also recorded. So in case you want to just go back to it and see, what you want to do with, certain things that you might have forgotten, you can just do that. This was sort of the basics. So this is what data science in law looks like. This is what you're going to be doing. So next session, hopefully, what we're going to be looking at is actual data. So what happens when we have not just one vector, but we have data. We have, data frames with thousands of rows and, tens of something columns. And you want to get elements from there. How do you get, only a specific row? How do you get a specific column and a row? And all that. Any questions, confusions, anything that you have?
So I wanted to ask when the next event will be, because I am actually the graduate student at Osgood School, and then we saw this, and I'm someone who's already into legal tech, so I'm really interested in all this. So first of all, I wanted to know when the next event is, and I really appreciate it because I understood everything.
Of course, no problem. Yeah. I think, what is it?
Around 2 weeks.
Well, here's the thing. So we wanted to hold these workshop series starting in September. There were so many events happening in September and October that we thought if we want to get, if we want to maximize participation, we might as well just start in November, which again, like we planned this and then we ended up having on the exam prep for 1Ls, which kind of was, yeah. So with that being said, well, I guess you guys are here. If you like this, if you're still, if you still want to continue, which we really appreciate, we were thinking either having another session in November, so late November, or moving all the sessions to starting January. So we're thinking of maybe like 4 more sessions, I think 4 or 5 more sessions. I think that's basically as much as you would need to just get to know the basics of our programming. So I'm hoping that by the end of it, you will be able to at least do some of the stuff that I showed you and, with the descents, with all those. And that's my hope. So out of curiosity, who thinks that, this should be done in January and February and March? Who thinks another session in November would be good? So for people who say November, let's just put it that way. Well, no, it could be. So we're going to have stuff in January too. It's just that we could plan another event this November. Yeah, so we can start in November.
Again in
Yeah. It's up to you guys. Sorry, one more time. Who said that wanted to be in November again? Sorry. Okay, so
we can do that.
that's a good amount. Okay.
Well, thank you guys so much
Yes.
for coming to the lit group.
I hope it was a little engaging. I know these are the basics, so it's not going to be as interactive. I try to make it a little bit interactive, but once you go through the basics, we're going to go through all of it together. So we're going to actually code along, and you're going to be able to just do it yourself without me telling you. So that's the hope going forward. Yeah, so that's it. Thank you. Sorry, yes.
Just a quick question. Where did you download the R Studio? Like, is there a particular website, or I'm also from Osgood, like, so
We
Wow, so
have
what are you doing for all of
we
it?
have it
So,
on our Eventbrite page, but we also will have the page to download our, available on our own website.
why don't you leave me your email address? And what I can do is I can send you the link with the instructions, okay?
I think so.
Of course, no problem.
Also, go on